Okay, here's the other one. This is going to cover 3 and 4. And we want the discriminant for this first one. The discriminant is b squared minus 4ac. So here a is 3, b is negative 2, c is 7. And I'm just going to plug them in. But when I plug them in, I need to put parentheses around numbers that I'm plugging in. Please, please, please do that. Okay, so it looks like I get here, this negative 2 squared is a positive 4, and then minus, and I just multiply all these together. So 4 times 3 times 7, which I believe is 84, which gets me a negative 80. Okay, here's what this tells us. Let me type this for you. Positive discriminant gets you 2 real roots. Let's change that. 2 x-intercepts. 0 discriminant. So if you got 0 for a discriminant, you get 1 x-intercept. And negative discriminant, you get 0 x-intercepts. Okay. That's the kind of solutions. Now, some teachers might also ask you for, I'm just going to copy this down here. Some teachers might ask you for this. A positive discriminant means that you have 2 real solutions to the quadratic equation. A 0 discriminant means 1 real solution to the quadratic. And a negative discriminant means you have 2 imaginary solutions. So again, be aware that there's 2 different ways to interpret a discriminant. I'm going to duplicate that page and keep that there. And now let's go ahead and clear this and do A. Uh-oh, nope, don't want to do that. That would be bad. Okay, using any method, let's do the method that makes the most sense for this one. I have something squared already, so I'll just isolate that. I'll get it by itself. I get x plus 4 squared equals 13. Looks like I'm going to take the square root of both sides. And I want to make sure I put a plus or minus root 13 here. And I get an x plus 4 here. To solve for x, I'm just going to subtract the 4 from both sides, and I get x is equal to negative 4, because I had to move the 4 to the other side, plus and minus the root 13, and that is my answer. Don't do anything else other than that. For b, I could try to factor. Let's see. If I know something times something equals negative 22, I know something plus something equals 16, I'm good to go, but I can't think of anything that would make that happen. So I gotta do quadratic formula, or I gotta do completing the square. And for this one, I'll use completing the square. So first of all, this is going to be completing the square. You can only complete the square when a equals 1. That's first of all. And our a does equal 1. If your completing the square is not a equals 1, if you don't have a equals 1 for completing the square, I would just default to quadratic formula. Because you can make a lot of mistakes with completing the square if you're not careful. So again, if a is not equal to 1 when you're doing completing the square, quadratic formula is probably your best bet. Let's see what we get here. We get x squared plus 16x equals 22. Okay, I believe we take b and divide it by 2 and square it for completing the square. And I know Reed does this, x squared plus 16x plus, and then he leaves a blank equals a blank plus 22. Maybe it wasn't Reed. Maybe this was one of his teachers from before that did this. It's a good idea. B is 16. So if we do 16 divided by 2, I'll put it over here. If we do 16 divided by 2, we get 8. And if we square it, I believe we get 64. Okay. And now what I'm going to do is I'm going to factor the left side. I'm going to add up the right side. That's 86. Now, the number that goes here Uh-oh. That's not what I wanted. The number that goes here is this number. So what we have here then for our answer is going to be x plus 8 squared. And now if we take the square root of both sides, doink, 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 I got x plus 8 equals plus or minus root 86. And that means I have to move this 8 over here, so I get x equals negative 8 plus or minus root 86. Done. Okay. Tough problem, long problem, but hopefully not terrible. Okay, vertex and axis symmetry from vertex form. Again, that's, oh boy, what happened here? Sure looks like oh geez. Oh boy. Okay. So it looks like, let's see here, I put that here. So when you're in vertex form, here's your axis of symmetry, and there's your vertex. So let's go and answer this question here. The vertex is going to be hk, so that's h, that's k, but really that's opposite h. So let's go and get our vertex. It's going to be opposite h, which will be negative 8. K stays the same. Your axis of symmetry is, so I call this AOS, is opposite h. X equals opposite h. And that's your answer. That's all you have to do for that one. And I can't tell you enough how necessary it will be for you to have these charts on your test. This one's going to be a long problem. Let's do elimination, because I said I would do that this time. I'm skipping graphing because it's kind of tough to do the graphing on the Smart Notebook. Okay, when you're eliminating, you want variables. I'll just type that out for you. Pick a variable. So to eliminate, pick a variable you want to eliminate. You want same number and opposite sign. And after that, add vertically. Okay, and what that means is I'm looking at my y's here, and I can see that my y's have a 1 in front. But one's a positive 1 and one's a negative 1, and I want opposite signs. So I'm going to multiply one of them by negative 1. And I'll rewrite both of them. So you get y equals x squared plus 3x minus 4 for the first one. And then I'm going to get negative y equals x minus 1. And I'm going to change how I wrote this here, because I want my x's to line up with one another. And I will note that it's a positive 1x. Now add vertically. So that's what that next step says. Add vertically. And I get 0 equals x squared plus 4x minus 5. Well, that looks like it factors. I think may have this right. Let's see. I think 5 and negative 1 will work. Yeah. So that means I'm going to get 0 equals x plus 5 and x minus 1. And if I set both of those equal to 0, maybe I'll get my answers out. Get x equals 1 out, or I get x equals negative 5 out. And that's it for these. Okay, for adding and subtracting and multiplying, I want to make sure that you're just aware that I squared equals negative 1, and i's come last. So let's add them up, or subtract these first. I get 3 plus 4i, and then again, a lot of students can pretend that there's a minus 1 here and it has to distribute it to both parts. We get a minus 7, and we get a positive 2i when we get to do that. Because I took the negative 1 and I multiplied by 7 to get negative 7, and I took the negative 1 and multiplied by negative 2i to get a positive 2i. And then I add, I get 3 and a minus 7. So 3 and minus 7, those are going to be a negative 4. And then 4i and 2i, that's going to get me a positive 6i. And that's my answer. For 2 plus I and 3 minus I, let's just start multiplying it out. I get 6. I get minus 2i. I get plus 3i by doing 3 times I, and I get minus I squared. I squared equals -1, or a different way that students are noting to do this is just change the sign of this -1 and drop the i's for I squared. So 6, this is a positive I, and then this is going to be plus 1. The reason it's plus 1 is there's a -1 there, and I squared is equal to -1, or I squared just means change the sign. Because before there's a positive 1, and positive 1 times I squared is -1. Just makes the sign negative. So my final answer here should be 7 plus I. And please note, i's come last. Okay, let's finish up by going ahead and solving this last one with complex solutions. I'll subtract the 17 from both sides, and I get -8 equals 2x squared. Okay, divide by 2 on both sides, and I get -4 equals x squared. And now let's take the square root of both sides. I get a plus or minus, I get x equals, well, let's see here, the square root of -4 is going to be the square root of -1 times the square root of 4. Well, the square root of -1 is I, and the square root of 4 is 2. So I get, this would be a fine answer, but most likely on an answer key you would see it as plus or minus 2i. Oh, I made some eyes. Ha ha ha. Oh, Mr. Lakin, you're so funny. Next one. We did that. Next one. So delete that page. Ooh, we exit slip 4. Yes, we made it. Woohoo! We're all done. Oh boy. Alright, let's go. Identify an equation as a polynomial or a non-polynomial. So a polynomial is going to be something like a variable to a number plus another variable to a number plus as many as you want of these. The number we have to be careful with. The number has to be a whole positive number. It cannot be a negative number there. We cannot have a any fractions there. You can have numbers in front of these variables if you want. Those numbers can be anything. And all this together makes a polynomial. So a variable to a number plus a variable to a number, and those numbers have to be nice. So here's what we have. Y equals 5x squared minus root 3x plus 1 over 6 would all be fine. I should add here that a polynomial could also just have one number, again, that could be any number that you want it to be at the end. Please also note that polynomials should have exponents that are decreasing. So this one had a 2, then it had a 1, and then it had no exponents. So exponents should decrease in a polynomial. Example of a non-polynomial would be something like y equals x squared minus 5 over x, or y equals root x. Something of that nature, where there's just a radical square root around the variable, or if the variable is in the denominator when it's not supposed to be. So I'll put a note here. No polynomials if there is a square root of a variable, not allowed, or there's a variable in a denominator. Again, not allowed. Okay. For an example of a 7th degree trinomial. So 7th degree means I need highest power to be 7. Highest power is 7. And a trinomial means I need 3 terms. 3 terms or 2 plus signs. So let's do the first part. Let's get 5x to the 7th, just because I like the number 5. Let's do minus 2x and plus 1. Those are 3 terms. The 3 terms are 1 2, 3. That's it. And again, there's lots of examples there. Okay, lead coefficient. The lead coefficient is going to be, and I'll type this one for you. The lead coefficient, is the number in front of the variable with the biggest exponent. And if I look through here, I find a number with the biggest exponent. And that number is, and that term is right here, negative x to the 9th. That 9 is bigger than everything else. And the number that's standing in front of it is a negative number. It's a negative 1. Yeah, negative 1. So negative 1 is my lead coefficient. Increasing and decreasing intervals. Number 1, left to right. So here's your rules. You have to go, oh boy. We have to go left to right. That's first. So look left to right. And then number 2, only x values. Do not give me y values for this or you'll get it wrong. So let's do increasing and decreasing. The red will be decreasing. The green will be increasing. Okay, so decreasing. We are decreasing from negative infinity. The reason I say negative infinity is because I cannot see an x value there. So cannot see x value. So if I can't see it, and there's no restrictions, that means, and I don't think there will be restrictions for you guys, that means that it's negative infinity. Now, what is the x value that we stop? Well, we stop right there at negative 2. Okay, next. Oh boy. Next, let's do the increasing. We're increasing from, again, from left to right. So from negative 2 to, man, I can't really see it because this arrow here. I really can't see where we can stop increasing. So we say infinity. And that's it for these. Next, keep it going, Mr. Lakin. Okay, end behavior. End behavior depends on the lead term. And I'm going to jot that down for you because that's a really important idea. End behavior depends on the lead term of the polynomial. And if you need a definition on lead term, again, it's the variable and coefficient with the biggest degree. Okay, so you will have to know some vocabulary here to be able to get this, take care of this. So let's see what we got. It looks like we have a biggest power of 3. We're looking at this lead term, and particularly this negative 5 is your lead coefficient, and it's negative, which means I'm looking in this column, and my power, my degree, is odd. My degree is 3, and I don't care about the 2x minus 1. So let's see where these match up. These match up right here. And that's my answer. So it look at what I have here. It says as x goes to infinity, f of x goes to negative infinity. And as x goes to, this should say negative infinity here. As x goes to negative infinity, f of x goes to positive infinity. And if you want a more thorough explanation than that, I'm happy to provide one for you outside of this video. You could find one online if you wanted to. There was one given to you for the notes when I wasn't here. But the bottom line is that this chart is going to be your big helper if you got a problem like this on the final and you're still not really sure what end behavior is. This chart. And again, if you'd like to find that chart, I posted it on Schoology for you right here. Make sure, again, you have that on your note card if you need it. Okay, let's finish up here because we're almost on 20 minutes. I'm just going to do synthetic division because it's easier and I think you guys like it. First, I'm going to just rewrite this the way I kind of like seeing these. It's going to be plus 2x minus 7. And this part, the divisor part, is it right here. Why did I leave a blank here? Because I need a 0x squared. Remember, I need my powers to go from highest to lowest and in order. Okay, so if we need a refresher on synthetic division, here it is. We take that, x's are dropped, that's number 1. And we take that negative 3 down, and we just go ahead and make it a positive 3. And we put a little box. And then I take each one of these numbers here, and I just line them up here. So we got 1, a 0, a 2, a negative 7. I always drop the first number, so always drop first number. Okay, and then once you drop the first number, you're really good to go. Let's just put that here, always drop first number. And the pattern is whatever number is in the box gets multiplied down here and goes to the next space up. So I do 3 times 1 and I get 3. And then I add. I'm always adding or subtracting there. And if there's no signs, add them. And I get a 3. And now I'm going to multiply 3 times 3. And I'm going to get 9. And the 9 goes right here. Then I add 11. Then I repeat, and I get 33. And I add, and I get 26. Negative 7 plus 33 is positive 26. Now, here's the kicker. So with each of these numbers, and here's a 1 here, don't forget, each of these numbers I'm going to put with an x now. But it's going to, I put 1 degree less than what I started with. So instead of x cubed, it's going to be x squared. And I'm going to put a 1x squared for that one. Then I'm going to put with this 3, a positive 3x. And then I'm going to put with this 11, a positive 11. And then with that 26, I'm going to put a positive 26 over x minus 3. And because polynomial long division takes 10 years to explain, I'm going to go ahead and just leave that alone and give you that as the answer. Maybe you don't need polynomial long division. That'd be cool. Okay, next, remainder theorem. Dun, dun, dun. Is that it? Oh my gosh, that's it. Yes! Actually, I'm going to show one more to you, the rubber band one. Okay, we won't tell you explicitly to use the remainder theorem, but it's a good one to know anyway. Basically what it means is you take this negative 2, you throw it in a box, and we do synthetic division on it. And the last number out is going to be the remainder. It's going to be the value that we want. I should note that if you have no idea what I'm talking about, you could always do f of negative 2. It's a little bit more work, a little bit to have to punch into the calculator, but it will get you the answer every time. So again, this is one alternative, option 1. Option 2 is right here. This is kind of a fun one. Okay, so let's see here. We got 9. Now I'm going to go and just multiply whatever number's here, put it there, and then I combine. So I get negative 20. And then I multiply. Get 40, and I combine. That's 45. Then I multiply, I get negative 90. I combine, I get negative 91. And guess what? That's my answer. I'll bet you money that f of negative 2 is negative 91. And for the final one, because we're already on 24 minutes here, let's go and take this polynomial. Let's do 7x to the 6th plus 5x to the 4th minus 3x cubed plus x squared. Let's change the numbers. Let's do, this is bad, hold on. I'm just going to make some slight changes here. Okay. Let's go and change that to a positive 35x to the 4th minus 28x squared. And let's just do plus 14x squared. And now let's say that we are dividing all of this by 7x squared. Well, this is what I like to call as a rubber band. I think Mr. Covey coined this, or someone else did. That's more clever than I am. So you may not have to show all the work, but basically I'm going to be writing down a lot with breaking this up. And that's really all I'm doing here. And then I'm going to simplify each one of these fractions to get me the answer. But I am breaking up, I am rubber banding, grouping each one of these together and simplifying. So let's see what I get. When I have numbers with letters, I do numbers with numbers first, and that gets me a 1. X, I got 6x's on top and 2x's on bottom, which is x to the 4th. In blue, I have 35 over 7, which is 5. 4x's on top and 2x's on bottom, which leaves 2 x's. And then similarly, not color-coded. Similarly, I get that for the green, and I get that for the red. And that's my answer. Thanks for watching, and I hope these help. See you in class.